Hi there, and welcome to our second lesson in Chapter 1. As we mentioned yesterday, today we're going to be talking about inferential statistics, and that really means using the data to make judgments about whether things are happening the way they should. Okay, so we're still looking at Westvaco employees, and these are the ages of the hourly workers who were in the second round of layoffs or who were involved. Okay, the ages there, and let's see, there are 10 of them. The ages that are shown are listed here, and I'd like you to, if you would please, pause the video. Let's come up with an average or a mean age for those employees. So we're going to add them all and divide by 10. Well, the sum was 464, and there were 10 employees. So the average age then was 46.4 years. Now, of these workers, only 3 were laid off. Their ages were 55, 55, and 64. Will you find that average quickly? Average age of 58 for the ones who were laid off. The average that we've computed here twice, technically called the mean, is a summary statistic, folks. And a summary statistic is a single number that's used to represent an entire data set, a single value used to represent an entire set. And an average is one of those, the mean, an entire data set. The mean is a summary statistic, the median is a summary statistic. There are many, but mean is what we're looking at today. So the average age of the laid off workers was 58, and the average age overall of employees was 46.4. So I'd like to have you look through this little dialogue between Martin, who's the man who sued, and the company Westvaco. Martin, look at the pattern in that data. All 3 workers laid off were much older than the average age of all the workers. That's evidence of age discrimination. Oh, Westvaco, not so fast. You're only looking at 10 people total. Only 3 were eliminated. If you switched out the 64-year-old with the 25-year-old, the average age would be totally different. Not so fast yourself. You picked the switch that was most advantageous to your case. Why not look at all the possibilities that could have happened? Well, what do you mean? Start with the 10 workers' ages and pick 3 randomly. Find the average. Do this a whole bunch of times and see what typically, another word for that is should, right? Should happen. So we have devised a way to do that. I have the ages of the 10 workers here, and I'm going to use a dice roller that I found on the internet that is a 10-sided die. I'm going to roll 3 times and keep track of the numbers that I get. I got 3, 5, and 7. So I'm looking at employee 3, 5, and 7 here. 35 years old for number 3. Number 5 was 48 years old. Number 7 was 55. What Martin is saying is over time, if we do that and find the average, so let's do that. It's 18, 8 and 5 is 13, 138 divided by 3, 46. Okay. If we do that many, many times and find the average age, then we'll have an idea of what should happen if things are totally at random. Now, I'm going to go ahead and roll my dice. I'm going to do 10 more trials of this simulation. I'll show you my results in just a moment. Here are the results of my 10 trials. I shook the dice 3 times, 10 different times, found the average age represented. And what I'd like to show you is how they fit in with a much larger simulation. 200 repetitions of this same simulated situation were done, and I've put my dots, or their approximate location, in with the rest, and you can see that mine kind of followed the same pattern. This simulation was totally age neutral. So based on this simulation, of which we now have 210 repetitions, this thing says what percent of the time, 210 repetitions, which percent of the time was the average age 58 or more. So here's the 58 column. 2, 4, 6, 8, 10 times out of 210. And ladies and gentlemen, that's a pretty small 5% of the time did we get an average age that was 58 or more. All right, this dot shows the variability in a variable, and that variable happened to be age. All right, continuing the dialogue, Martin here. Look at that pattern. All 3 of the workers laid off were much older than the average. Westvaco, so what? We've seen that it could happen by chance. Well, sure, you could get that result by chance, but is it easy or hard to do? It is really hard to get that result by chance, but that still doesn't prove discrimination. No, Martin says, but I think it leaves you with some splaining to do. And the question, of course, is how unlikely is too unlikely? How small would that percentage have to be if you thought it would qualify as unlikely? And I will tell you that the experts usually say 5% or less is unlikely. So performing a simulation such as we did with the dice rolling, it can be a very useful tool for inference, and that is making judgments about whether a situation is behaving as it should. And you have to be a little bit more clear about that, as it should, based on total randomness. Or as it should if it were happening totally random. Now, I want us to talk about this idea of simulation a little bit. The key steps in a simulation are coming up with a model that models the situation randomly. It must be random. And what I'm talking about there is when we shake that dice, the numbers, any number 1 through 10, was equally likely to come up. So whatever came up, that was a random chance. The next thing is to do many repetitions, folks. The more repetitions you do, the better in a simulation. You get more reliable data the more you repeat. So many repetitions. Then look at a distribution. And we did that with our dot plot. And finally, make your judgments or draw conclusions. Alright, I'd like to show you how you could have done that last simulation using your calculator to generate random numbers. That is to select 10 numbers from a set of 10. It's under Math and PRB. What we're going to ask it to do is option 5 here, rand_int. We want our numbers to come up from 1 through 10, so it's start, comma, stop. We needed sets of 3 numbers from that range 1 to 10. So on your calculator, if you random int and then start, comma, stop, comma, number of numbers. Alright, my first time doing that, you can see I came up with a repetition in the numbers, and that's really not allowable. You can't lay off that same person twice. So I'm going to hit enter again. I don't have to reprogram, it just does it itself. Okay, I got employee numbers 3, 4, and 5 there. Then I would figure their ages in total and divide for the average. But let's get the keystrokes for that down here. What we did was went to the math key, over to PRB. We chose rand_int. And the way the numbers went in the parenthesis, it was start, comma, stop, comma, number of numbers that you need. So we had a 1 to 10 and we needed 3 numbers. That's what our example looked like. So the last thing I'd ask you to do, and I would like you to take your calculator or flip a coin. We want a simulation of flipping a fair coin 10 times and find out what proportion of your flips were heads. So on your calculator, if you were going to do that, it'd be rand_int, start with 1, go to 2. That is, you're going to get 1s and 2s out of there. You're going to decide which of those is going to stand for a head, and you need to do that 10 times. So I'm going to let 1 be my head, and I'm going to do mine right now. In my trial, I got 5 out of 10, or half the time, heads, which is exactly what you would expect. That's the end of our lesson for today. I'm going to ask you to get out there and try the U-Try right now. We'll see you in school.